Hello everyone! Today we will see the second part of the Introduction to Reinforcement Learning video series. I'm Eduardo Garrido and I have the pleasure of being a lecturer at ICADE, where I specialize in machine learning and statistics. Let us discover more reinforcement learning theory together. We will begin with actions and rewards. We'll explore how agents learn from their interactions by seeking rewards, a process that is both fascinating and fundamental to how learning occurs in this paradigm. Our discussion will then move to the environment and the states, the settings in which reinforcement learning takes place. Understanding these concepts is key to grasping how agents perceive and interact with the world. Autonomous agents work with a policy. The policy is a critical component of reinforcement learning. It's the strategy that an agent employs to determine its actions. We'll examine how policies are developed and refined in the context of reinforcement learning. Then we'll dive into the practical aspect of the reinforcement learning algorithm, the Q table. This is a method for helping agents evaluate the best course of action in a given situation. As we wrap up, we'll reflect on the key insights from our session, discussing the implications and potential applications of reinforcement learning in various fields. Finally, we'll conclude with references and further reading materials, providing you with resources to continue exploring this fascinating world of reinforcement learning beyond our session today. In this section, we'll dive into the core concepts of actions and rewards in reinforcement learning. First, let us talk about action choices. This is akin to a chess artificial intelligence deciding its next move. Just as the artificial intelligence evaluates the board to choose the best piece to move, reinforcement learning involves assessing the environment to decide the next action. Next, we have immediate rewards. This is the immediate feedback received from actions, similar to scoring points in a game after a successful play. It's a crucial aspect of learning, as it provides direct reinforcement for specific actions. Moving on, we consider long-term rewards. Unlike immediate rewards, these have cumulative benefits of actions taken over time. Think of it like the overall health improvement seen in a fitness app user over months or years. This aspect emphasizes the importance of strategic long-term planning in reinforcement learning. Then there's reward maximization. The goal here is to increase the total rewards over time. A practical example would be a portfolio management system that aims to optimize returns. This is about making decisions that maximize the overall gain. Finally, we have the feedback loop. This involves continual adaptation based on the outcomes of previous actions. A good example is a recommendation system that refines its suggestions based on user interactions. This loop is crucial for the ongoing improvement and refinement on the learning process. In summary, understanding actions and rewards is fundamental to developing efficient reinforcement learning models, as they guide the learning process towards effective decision-making. Now, let's move on into the intricate aspects of environment and states in reinforcement learning. First, we discuss complex environments. These are varied settings where agents operate, such as a robot navigating through a warehouse. This complexity challenges the agent to understand and adapt to a wide range of variables and conditions. Next, we explore state representation. This refers to how the agent perceives and understands its current situation, similar to understanding the positions of pieces in a chess game. It's crucial for the agent to have a clear and accurate representation to make informed decisions. Then there is changing status. This involves the dynamic evolution of the environment in response to the agent's actions. A practical example is how traffic patterns change from a self-driving car, requiring continuous adaptation and decision-making. We also have state transitions. This is the process where an agent moves from one state to another, often as a result of its actions, akin to a player moving to a new level in a video game. This concept highlights the impact of actions on the agent's journey and progress. And lastly, environment feedback is critical. This is the information that the environment provides back to the agent, aiding in its decision-making process. An example would be how the market trends influence a trading algorithm, guiding it to make better trading decisions. In summary, understanding the interaction between the environment and states is fundamental in reinforcement learning, as it directly impacts how an agent learns and makes decisions. In this segment, we're going to move into the cornerstone concept of policy in reinforcement learning. Let's break it down. At its core, reinforcement learning involves learning a policy. And what is a policy, you ask? It's essentially a strategy or a set of rules that guides an agent's actions in various states. The policy assigns an expected value to the probability of choosing certain actions in given states. But it's not just about any action, it's about finding the best one. The policy is learned with the objective of maximizing the expected value of the future reward. This means that the policy guides the agent to make decisions that are not just beneficial in the short term, but also in the long run. How is this policy learned? Well, it's through a process of trial and error during the training phase. The agent interacts with a simulator of the environment, making decisions, observing outcomes, and gradually refining its policy based on the feedback it receives. It's like learning to ride a bike. Initially, there might be a few wobbles and falls, but over time, the rider learns how to balance and move forward effectively. In essence, the policy is a function that tells the agent what action to take in a particular state. It's like the agent's guidebook, learned through repeated practice to navigate the complex landscape of decisions and actions in the environment it operates in. To sum up, understanding and developing an effective policy is crucial in reinforcement learning, as it directly influences the success and efficiency of an agent in achieving its goals. In this part of our presentation, we are finally going to explore the Q-table, a critical element in reinforcement learning, particularly in the so-called Q-learning algorithm. But firstly, what does the Q-table represent? Well, it summarizes the expected value of each action for every state. Imagine it as a comprehensive guidebook that lists the potential rewards for every possible action the agent can take in each state it might encounter. The role of the policy here is straightforward, but yet crucial. The policy in this context would be to choose the action that has the best expected value in each state. It's like having a cheat sheet that tells you the best move to make at every turn. But how is this Q-table learned? Well, this is where the Q-learning algorithm comes into play. It's a process of discovery and refinement. The agent, through trial and error, learns the value to be entered in the Q-table. Each entry in the table represents the expected reward for taking a certain action in a specific state. So the agent updates these values as it learns from the outcomes of its actions. In essence, the Q-table is a crucial tool for the agent. It enables the agent to quantify the potential rewards from its actions and make informed decisions based on this knowledge. Over time, the agent interacts more with its environment. The Q-table becomes increasingly accurate, guiding the agent towards more optimal actions. In summary, the Q-table is the backbone of the Q-learning algorithm, capturing the essence of the expected rewards for state action pairs and guiding the agent to make decisions that maximize these rewards. As we wrap up, let's recap the key insights for a fascinating exploration of reinforcement learning. We've discussed the key components of reinforcement learning, which include agents, environments, states, actions, and rewards. Each of these elements plays a vital role in how the reinforcement learning functions and learns. A highlight from our discussion was Q-learning, a widely used reinforcement learning algorithm. Q-learning employs a Q-table to store and incrementally update the value of action state pairs, providing a foundation for agents to make informed decisions. In conclusion, reinforcement learning represents a significant step forward in our quest to create intelligent, adaptable systems capable of tackling a wide range of real-world challenges. Finally, I would again like to recommend some resources where you can learn about reinforcement learning. First one, the seminal book Reinforcement Learning and Introduction by Sutton and Barto, published in 2018 by MIT Press. This book is a fundamental text in the field, providing theoretical underpinnings and practical insights. Next, the famous Powell 2021 work From Reinforcement Learning to Optimal Control, a Unified Framework for Sequential Decisions. It is a complete book that has all the theory behind reinforcement learning. And finally, the Reinforcement Learning course, which is my favorite, by Hugh and Face, which provides hands-on experience and insights into the latest advances of another exciting topic that is called deep reinforcement learning, where deep learning and reinforcement learning work together to solve complex scenarios. Thank you for your kind attention and again for arriving until the end of this video. And please do not hesitate to contact me if you have any doubts about this exciting topic. See you again in another video.